Hi everyone, this is the second lesson of mechanics. Today we're going to do simple harmonic motion. I just want to let you know this video is going to be quite long, so have a bit of a break in between and watch more than once. Okay, what is simple harmonic motion? So let's have a look at that. A particle which oscillates backwards and forwards in a straight line about a central point is said to be moving in simple harmonic motion. So it's like up and down, you know, or left and right and backwards and forwards. Okay, so that kind of, it's almost like there's a straight line but it's got a pattern in it, you know. So therefore simple harmonic motion is any motion whose displacement x and time t graph is a single sine or cosine function. Okay, so if you look at the sine and cosine wave or function, that's where it's like moving up and down or left and right, and you know, it's like wave in the ocean. Okay, so that's simple harmonic motion. It's got a pattern in it. So let's have a look at that. So that's the amplitude, because highest one and the lowest, and then the n here it's using to find the period. In this case sine and cosine, so it'll be 2 pi over n, and a particle starts its motion at the center origin. Okay, so that's a 0 0 x-axis. Not all of them will be like that, but this one it is. Before I go any further, I would like to show you this little diagram that's a little bit looks complicated, but it's not too bad. What will happen during the simple harmonic motion? What will happen to velocity and acceleration? Okay, so it's like a pendulum here, and it didn't move, so it's a center, so displacement is 0. Now, when the pendulum starts from say up here and go down and hit right in the bang in the middle and go up, that's when it's the fastest. Okay, so therefore your velocity is maximum here in the center, and because it can't go any faster than what it is, because it's a velocity is the max, your acceleration is 0. So let's put some numbers in so that it's easier for us to understand. So displacement is 0 because the center, you didn't move. Velocity is a 10, for example, and acceleration is 0 in the center. So it's moving to the right first, so that's a positive and that's negative. Okay, moving to the left is negative, right is positive. So if you move to here, it's still displacement is a positive, isn't it? Okay, keep moving. It's on the positive side, and velocity is positive, but it's decreasing. So if you look at center here, your velocity was 10, but when you move to here, your velocity is 5. It's still positive, but it's a decreasing, isn't it? So therefore your acceleration is a negative. Okay, and then you move more to the maximum place. Okay, so this displacement is your amplitude, the positive amplitude, and because it reached the highest point, your acceleration just stops. No, I mean velocity will stop. So velocity is 0. You know, when it's hit, it stops for a second before it changed direction. So that's the point there. Because it was decreasing velocity, your acceleration is minimum on this point. Okay, so velocity and acceleration is like go together. When velocity is increasing, acceleration is positive, and when velocity is decreasing, acceleration is negative. Now it's hit the maximum place and it's going down. So here, okay, so here displacement is still positive because all this side is positive. Velocity is a negative now because it was 0. It's changing direction, so your velocity is -5 now. Okay, so therefore it's negative velocity, and also it's decreasing, isn't it? Because it's 0 to -5, it's decreasing, therefore acceleration is negative. And then it comes to the center again. So what happens here? Displacement is 0, but the velocity is now minimum, not maximum, minimum, because it's -10, because it's a -5, now it's -10, and acceleration is still 0. And then it goes up here, and now it's a displacement is all in the left hand side, which is negative. Now velocity is a negative, still negative, because it's -5, but from -10 to -5, that's increasing, right? Therefore your acceleration is positive, so be careful with that. And then you go to hit the maximum on the left, which will be your negative amplitude, and because it hit the highest or lowest point, your velocity is 0. Okay, the 0 point there. And then what happens with acceleration? It becomes a max, because as you can see, it's been increasing, right? It's busy increasing, and then it goes down, go hit, and then come back, and same thing happens here. This time is velocity is 5, because it's on the same, like to the right, which means it's a positive. When it was going to the right, it was positive, wasn't it? It was left, it becomes negative, so it's increasing, and then you go back to where it was, and it keep going, same pattern. Okay, it's pendulum. All right, so there is some information. Sums up the velocity is a maximum when x equals 0, the displacement, and acceleration is 0 when x equals 0, which is the center right there. And when the velocity is 0, which was each end, the highest point on each side, the x displacement is the amplitude. Okay, so that's what this one is. All right, next one. Let's have a look at it a little bit more. So a particle does not start its motion at the center origin. You will have these two types there. So when it was moving at origin, it was, do you remember, a sine and t, or x equals a cos and t. So that's definitely starts at origin. But when you start having alpha, because it's a phase shifting, moving like left to the 90 degrees or right to the 90 degrees or something like that, and then we'll have a center. Center might not be 0 anymore, it might be 8 minus 1, could be anything. Okay, so that's the case. Now, acceleration, it's equals minus n square x. Now let's prove this one. So I'm gonna, because the simple harmonic motion can be either this sine curve or cosine curve, so I'm gonna actually prove both sides and then see how we go. So x dot is my velocity. I'm just going to differentiate this. It'll be a cos nt plus alpha, differentiate the whole thing, will be n. So it'll be, I'm going to put n a cos nt plus alpha, and I'm going to differentiate again, and this time cos to sine, it'll be negative n a sine times n. So what's happening here? I'm going to put n square, a sine and t plus alpha. Now you can see that's the same as this, right? So I can write n square x, which is, that's what it is. Now let's have a look at this one. So what will happen with the other one? So x dot equals this time minus a sine nt plus alpha times n. So I'm going to put minus n a sine nt plus alpha. And I'm going to do one more time, so minus n a cos, because it doesn't change, nt plus alpha times n, which is minus n square, a cos nt plus alpha. That is same as x. So therefore, I'll get the exactly same proof. Okay, now just a little note, this equation, the acceleration equals minus n square x, is usually the most straightforward way to test whether a given motion is simple harmonic motion with center, the origin, or C. Okay, so when we have a C here, it doesn't really matter because when you differentiate, it will disappear. So you still get the this expression. Okay, let's have a look at the velocity that we just looked at the acceleration now, the velocity here. So we need to prove this. In simple harmonic motion, the position of the object is proportional to the force acting on it. This force acts in the opposite direction to the displacement. So I'll put the force as a capital F, opposite direction. Now, proportional, it means like y equals minus kx. Like it's a minus because it's opposite, okay? And I'll put the x there because it's displacement, all right? So therefore, force equals minus kx, force equals minus kx, but also force is ma, which is mx dot dot, okay? So I'm just equating this and making it in terms of making the acceleration the subject. So when I do that, I'll get this, and this can be written as a square root of, and then square them. So my n is that. Now, what does that mean? It is the, I can actually write acceleration in terms of the x, okay? Because we did have x here. So I got v, like a v squared, I've got n, I've got 8, I've got x. So I need to think about all those things. So I'm going to use this, equating it, and then integrate them. So when I integrate this, I'll cancel this out, or left to that, and I integrate that, I'll get this plus c. So when acceleration is, no, sorry, this is not acceleration, it's a velocity is 0, which is when the pendulum was on the highest peak point there, okay? And that's what I'm going to use. So I'm going to substitute when the velocity is 0, the x reaches the max. So when I do that, I'll get the constant as this, and I put it back into there. I'll get this one, and I'll times by 2 all the way, and then I'll take the n square as common, positive n square as common factor, and I will get this. Okay, so that's what it is. Let's sums up a little bit. So a simple harmonic motion about the x is a center. Okay, center is not an origin. These are the formula that we need to use. Okay, that's plus c, same. And what if it was origin? Exactly the same, it's just that this one didn't have the c in it. Okay, so that's what it is. All right, so let's have a look at the question now. Let's do questions. So it's not too bad, this one. So there's over 3 examples in the question 1 that show, you have to show that motion undergoes simple harmonic motion. Okay, when it says simple harmonic motion, whenever its question said prove simple harmonic motion, it just means prove this. That's all. Okay, so let's have a look. I'm going to differentiate that. Cos differential minus sine t plus pi over 3, and that's differential of that is 1, so it doesn't really matter. Next one, cos, same, okay, but this is x, isn't it? So I can rewrite this as this. Now how am I going to change this one to this? Well, if I do that, your n is, it's the same as, right? So therefore, it's a simple harmonic motion. Next one. So I'm going to do same here. 3 cos 2t minus pi over 2 times 2. Okay, 2. So 6 cos 2t minus pi over 2. And then I'm going to go to the next one. 6, but this one negative, sine 2t minus pi over 2 times 2 minus 12 2t. Now I need to change this one into something like that. So I'm going to go 4 times 3 sine 2t minus pi over 2. So 4 times 3 is 12. So therefore I can write this one into x, which I can rewrite this 2 square x, which is same as that. So therefore this is simple harmonic motion. Alright, so that's not too bad. Now this one's a little bit different, but not too much, not too much. So let's have a look. X dot, I'm going to go minus sine 2 sine 2t, because that 2 had to be come out, minus, I'm going to do 6 cos 2t equals, that's the same, 4 cos 2t. Now cos becomes negative sign, so it becomes plus 2 times 6, 12 sine 2t. Now I need to make this in from here, so I'm going to take 4 out. Oh, look at that. So that is x. So that means, so simple harmonic motion. Excellent. So that's what we got. Now next question is quite long, but we can just read a little bit and see how we go. The rise and fall of the tide is considered to be simple harmonic. The interval between successive high tides is 12 hours. The wharf entrance has a depth of 12 meters at high tide and 4 meters at low tide. The high tide occurs at noon on a certain day, and there are about some questions in there. There's one more. All right, so it goes A, B, C, D, E, F. So let's have a look at some of the questions now. So let's do the graph. We're gonna do some graph here. So the question says something like, I'm gonna do something. I'm gonna put this away, and then I'm gonna do this A. So graph will be, that's my t, that's my x. As you can see, high tide happens at noon. That's the starting point. So it's cosine, because it doesn't start from 0. Okay, it starts from high tide. I'm not going to put t there. I'm going to just leave it as it is. Okay, so so far that's what I've got. So that's my high tide, and that's my high tide, and that's my low tide. Okay, and maximum, what was the maximum? The high tide was 12, wasn't it? Okay, depth of 12. So that's a 12 meters. Okay, meters, 12 meters. and low tide was 4 meters. Okay, so what will be my center, middle? 12 plus 4 divided by 2. So it would be 8 meters. Okay, so that's what I've got. Excellent. And then it takes, whole cycle goes 12 hours. Okay, that's my 6 hours, and that's 12 noon. Okay, this starts with 12 noon. Okay, I think that's what I've got, so I'm gonna go, that's my T, that's my 0. So that's what I've got. Okay, so whole thing was up and above the x-axis, because my center is 8, my high tide is 12 meters, my low tide is 4 meters. Okay, the whole cycle from the period of the whole one high tide to the other high tide is 12 hours. So that's a bang in the middle, so 6, and then the whole thing starts at 12 noon. Okay, so that's my the graph. Now the B, let's have a look at the B. What's N? Find N. Now the period was 12 hours. Okay, it says that in the question. That means 2 pi over n is 12, because it's a cosine. So therefore my n equals 2 pi over 12, which is pi over 6. So that's my n. And what's my C said find the amplitude. Now if you look at amplitude, if this was my center, that should be my amplitude, right? So 12 take away 8, my amplitude equals 12 take away 8, which is 4. 4 meters is my amplitude. Okay, and D says find my center. Center was 8 meters. Okay, so we're getting somewhere there now. And then I'm going to have to find equation of the motion now. Now this one we know that's going to be cosine, isn't it? So A cos n t plus alpha plus c. Okay, because it doesn't start from origin. Now what was A? 4. N was pi over 6t plus alpha, I don't know, and center was 8. Okay, we got so far so good. Now from the diagram here, when t was 0, right? T was 0, what was x? 12. Okay, so I'm going to substitute. When t equals 0, x was 12. Okay, so I'm going to substitute that in. So 12 equals 4 cos, that would be 0 alpha plus 8. So now 4 cos alpha equals 4. If I move that, cos alpha equals 1. When is the cos alpha equals 1? It's 0, isn't it? The first one, right? Okay, so therefore alpha equals 0. Most of the times alpha is 0. So, and therefore my equation is cos pi over 6t plus 8, because alpha was 0. There you go. So that's our equation. Now, next question, it says here, find the time interval that a ship 7 meters long can pass through the entrance. Okay, so let's have a look at the graph here. I'm going to sketch this again. So oh God, this time I'm going to just do a little bit better. 8, that's 12, that's 4. Hey, if you can see, that'll help. X. Okay, so that's a 0 there. And I'm gonna go roughly, okay, sort of like that. And from here to high tide to here high tide, right, it's 12 hours. Okay, so here 12 hours, and here middle 6 hours, and 12 noon. Okay, so that's what I've got. Now let's think about this. Is it, the ship is what, 7 meters long. Water cannot be higher than 7 meters, otherwise you can't get in, right? So water can't be higher than 7 meters. So 7 meters here, right there, sort of. Okay, so we need to find here and here. Okay, so that's the time. That's the time interval we have to find, okay, to get in. So let's have a look. So I'm going to use a smaller pen. When x equals 7, what will be t? Okay, so that's the whole question. Okay, that's what we have to find. So let's have a look. What was our formula? X equals 4 cos pi over 6t plus 8. And I'm going to put 7 into x there. So 4 cos t equals minus 1, because I'll put that in there. Now, cos is what? Let me see, cos pi over 6t equals minus 4. When is a cos negative? It is second and a third. Okay, so let's have a look at that. And it's all in the radian mode, so use your radian mode in your calculator. So pi 6t equals cos, okay, minus 1. So that 4 equals, okay, just watch what I'm doing here. So I've got first and the second, second and first, so it'll be pi minus theta, pi plus theta, yeah? So what I'm going to do here is I'm going to go pi minus cos 1 over 4, and then pi plus cos 1 over 4. That's what I'm going to write, okay? And then, therefore, t times by 6 over pi. If I do that here, I will get 6 minus 6 pi. I mean, you can just use a calculator, but I just want to use a calculator later on, all in one go. 6 plus 6 pi cos minus 1 over 4. Okay, so hopefully you understood what I've done. Okay, and if you use calculator in a radians mode, you get 3.4826 and 8.5174. Now what that really means in the times, you probably need to use the little degree, minutes and seconds to do this. So if we do that, you will get the time. Okay, so let's have a look at the time one. So if I put this one in there, you will get something like 3 degrees 28, 57.3. and here you get 8 degrees 31 minutes and 2.7 seconds. So if I change this one into hours, it'll be 3 hours 29 minutes, because that goes rounded up. This one though, it's 8 hours 31 minutes, because that's less than 30. Okay, from the 12 noon. So your time is, because this is what, from 12 noon, so which is 3.29 p.m. 8.31 p.m. So that's your interval. So as long as the ship goes into between this time, it can get into the entrance. Okay, well done people.